All right. If I was looking at the first one and we want to work out 2012, you're looking here, which if we line that up with the y-axis, hits at 70. Unfortunately, they haven't given us any units on this side. Normally you would have units, but in this case, we'll just say 70. It does, however, it does say up here, dollars made in the thousands. So normally it would say it's somewhere on the axis, but that, since it says dollars made in the thousands, it's going to be $70,000. Which year was the least amount of profit made? Obviously, that's 2011 with the smallest bar. CEO claims that their company's on the rise and is ready to grow and expand some more. Does this graph support this suggestion? So you could say one thing I might do is show this like trend line here. So if I say C red trend line in 2011, sales were about $10,000. And I would just, because it asks for mathematics and reasoning, as obvious it is, I'm just going to quite literally spell out what's happening. So in 2012, we said there was about $70,000. And I'm just going to jump straight to 2014 because I'm running out of space here. We're about $150,000. So I would say, therefore, I'm running out of page space. Do it on the next page. Therefore, the CEO claim is valid. The profit has increased every year since 2011. So something like that would be adequate. This one here is arguably the hardest question, I think, that I gave you guys in this practice test, only because you have to work out how to make these axes. And I didn't actually know this before I designed it, but putting in the 1050 really messes us up, because otherwise you'd be able to go up 100, 200, 300, and so on. But you get to here, which is 1,000. And so I could just make up here 1,050, but I'll try doing it slightly differently. Okay, if you did that, that's okay. But I'm going to go up 150, 300, 450, 600, 750, 900, 1,050 there. So that'll work decently well. Obviously, there's all this space up here that I'm not using, which is not perfect, but I would not drop marks for how much I've used here. This would be fine. Then if I'm looking at the x-axis, I have 10 years split across 1, 2... Yeah, I know, it doesn't update straight away. Yeah. I have 10 years split across 1, 2, 3, 4, 5, 6, 7, 8 spots, which is, once again, really tough. Hopefully the actual test is more thought out than me making this on the spot. I'm going to go ahead and split these in half, which is not great, but it does mean we can fit every single one. And I'm only going to write in every second one. So that first one would be 2010. Just so 2012, just because I'm not going to have enough space to fit right in every single year. So 2013 would be that year there. Just to be clear, that's 2011 there. 2015, 2017, 2019, that should be on that line there. And then halfway there would be 2020. Always good too to put the labels in. So I have the years down the bottom here, not the neatest handwriting. Apologies. And then up the x-axis, number of vet admittance. I don't know if I've made a word up there, but something to describe the situation. In our case here, we're talking about cats and dogs. Now, when we have two variables like this, in this particular case, I'm gonna make a line graph. Not saying that's the only one you could do, but that's the one that seems most intuitive to me. I'm going to label the cats as orange and the dogs as yellow. And that way I've got two very clear lines down here. If we have a look, the dogs start out with just 10 in 2010. So I'll put a little yellow dot down here. In 2011, they go up to 200. Bear in mind, I'm going to probably do this a little bit on the rough side, just for the interest of time. So we'll keep going. 2013, they went all the way up to 500. 2014, we're at 600. 2015, they were at 700. So I'd be up to this one here, still doing the dogs. So 2016, they're up to 800. 2017, they're up to 1,000. So around about there. And then 2018, they're all the way up to 1,050. 2019, they're back down to 1,000. And then 2020, they're down to 950. Whoop, I went a little far there. Cool. All right, now we'll do in orange. We're going to do the cats. So the cats start out at 1, which may as well be 0. And then 2011, they go up to 100. 2012, they're going to go up to 300. 2013, they're going to go up to 400, sorry. 2014, they're at 450. 2015, they'll be at 700. Sorry, misread that. 2015, the cats will be at 500. 2016, the cats will be at 500 again. 2017, they actually go down to 450. 2018, they go up to 600. And 2019, they go up to 750. And 2020, they get to 800. All right, cool. Last thing for me to do now is to connect all my dots. So orange to orange. If I had a ruler here, this would be better than me doing roughly straight lines. All right, and then in yellow, remember that was a yellow dot there, and then we're up to there, 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 all the way up, across, there, there. Cool. And then I've done the dodgy one there, but it's nice to do an official legend where I say this is the cats and this is the dogs. All right, cool. The next part says, why did you choose this type of graph? I'm going to say that the table represented numerical, right? So that would be a key mathematical term, as in numbers. Numerical data that changed over time. A line graph displays this effectively. Cool. Describe the change over time for the cats admitted. The cats increased until 2017, where it looks like they hit a little hiccup. So you can see, trying another color. You can see there, they had their little hiccup. And then apart from that, they went up. So I would say the number of cats admitted increased until 2017, where it dropped before continuing to only increase. Cool. All right. And then we would be up to question 3. So this is a step graph, which it's been in the textbook a few times, but I haven't done a worked example with it yet. So this is a good chance for me to do a quick little bit of teaching. If you guys look here, you can see that there are both closed dots and hollow dots. This graph here works exactly the same as a line. Exactly the same as a line graph. Where you see the hollow dot, it is not included. Where you see the closed dot, it is included. So for example, if the question asks us at 1 kilo, how much is packaged, you can see that both that one there and that one there line up with a kilo, but we focus on the closed dot. The closed dot is what is included, so we line up them with the y-axis there, which is $1.40, because there's 1, 2, 3, 4, 5 increments from 1 to 2, which $1 divided by 5 is 20 cents, and there's 2 there, so 2 lots of 20 cents. We would have option C, $1.40. If I have $4, what's the largest package I could post in kilos? I would go across from the 4 kilos, and I would see nothing lines up with it directly. If I was to hit somewhere on this line, though, I would have to go above 4 kilos, which above $4, sorry, which I don't have. I've only got $4, so I can go a little bit below to this line here, and we can see with this little bit less money, it looks like $3.75. I could, and that lines up with there, I think, I could post something worth 5 kilos as a maximum. Okay. Next up, we have our two-way table. Very nice. All right, two-way table. Remember, across from left to right, they're going to have to add up. So 21 plus something has to equal 32. That something is going to be 11. And then we can see 32 plus 31 in the totals. They have to add together to give us our grand total, which is going to be 63. And then last one here, 21, again, plus something equals 42. That something is going to be another 21. All right. Answering the questions. Part A, what was the total number of plants on the survey? It was 63. How many plants had over 41 tomatoes when fertilizer B was used? So when it says tomatoes, you can see that they are the fruit that it's referring to. So over 41, we're looking in this category here. And then fertilizer B is the second row, so we're looking at this number 10 here. So there was 10. How many plants had 40 or less fruits grown? That is this category here, and we can see its total was 42. All right, second last question. The following graph shows the average monthly rainfall in Brisbane and Melbourne. Obviously, it's in colour on this video, but for you guys, it was black and white, so I added that so it was clear. So we're looking at Brisbane and Melbourne there. The question only asks about Melbourne in October, which is over here. Melbourne is the green line, so we go up to the green line, which brings us across to 60, pretty much anyway. So it's roughly 60 mils, or my answer would be B from those multiple choice there. All right. Oh, sorry, my bad. There was 2 more questions. The height of a plant in millimeters is recorded in the graph below. What is its height on day 5? On day 5, we would go up from here and then go across. To me, we're between about 35 and 40, somewhere in between there. It's definitely above the 35 line, so I'm going to call it 37, option C. Last one, unit conversion to go from 104 degrees Fahrenheit, so right about there, to a temperature in Celsius. So we will go, once again, follow up. We hit about there, go across. We're going to be pretty close to the 40 mark. Oh, wow, they're giving us some tough answers there. So they're really asking if it's 39, 40, 42. To be realistic, guys, on the test, most of those would be acceptable. For 104, so let's look at this closely. For 104, we are sitting, if we look here, there's 1, 2, 3, 4, 5 jumps from 100 to 120. So that's a space of 20 increments split across 5 jumps, which means each increment is worth 4. 20 divided by 5 is 4. So this first increment is exactly 104. So getting more precise now, we can see that that lines up exactly with the 40-degree line coming across there. So it is exactly going to be 40 degrees, or option C.